Okay, hey everyone, I'm Rishabh and I'm here presenting the new MobileRAG, which is the future of on-device retrieval augmented system. And I'll go ahead with the presentation. So these are some challenges that we currently have. We have some memory walls, which is mobile device has typically less RAM, like 4 to 12 GB. Much of it is consumed by operating system, and then there is power drain because we have limited CPU intensive operations, and it requires CPU intensive computation requires for distant calculations during retrieval and LLM generation. And then we have the latency cycle, which is time to first token. It is critical metrics for user experience trying to track often feed overly large inputs around 200 2000 tokens to the large model. And then we have these kind of rack systems that are already available, like native rack, advanced rack, and edge rack. Native rack does this generation speed is pretty slow, as it uses entire 2000 token inputs. It's high inference latency, poor UX, and then it feeds all the top k documents to the LLM. The advanced RAG is secondary ranker model, which has heavy computation, does re-ranking, which adds significant overhead and increases the memory and processing demands. Third is the edge RAG, which is optimized indexing for based on the searching the correct documents, but it's inefficient because it inefficient generation still feeds full documents and then drains power during the critical generation phase. So we need a solution to optimize both the retrieval and the generation phase for input mobile efficiency. So we have introduced this MobileRAG, a unified on-device solution. It is fully on-device pipeline specifically engineered to overcome the limitation of mobile AI. It integrates two innovative components that work in tandem to optimize both retrieval and generation stages, delivering privacy first AI directly. Then the two components are EcoVector and SCR, which is EcoVector is the retrieval engine. It is a hybrid RAM disk vector search architecture designed to minimize memory footprint without compromising search speed. And it intelligently manages index storages retrieves for optimal performance. And then SCR is selective content reduction. It is a sophisticated method to filter, compress a retrieving text. And it also reaches the SLM, which is a small language model. This significantly reduces the LLM input size. So we can achieve 100% offline operation first of all, and then ensures robust user privacy and drastically reduces the battery consumption. So this is pretty good advantages that we have with the MobileRAG system. Then how does it work internally? Now we have EcoVector architecture. In this we are having cluster partition, dual graph structure, and inverted list graph, which is the disk. So in the cluster partition, vectors are grouped into a distant cluster using a technique like k-means, and each cluster is represented by central point or the centroid, simplifying the overall search space. The dual graph structure is a centroid RAM, effective HNSW graph comprises only the cluster centroids. And then the inverted list graphs, this actual data search within each cluster are organized into independent HNSW graph, and these larger detailed graphs are stored on disk, so only necessary clusters are loaded when required, and significantly saving the RAM. So this is how it works. We are partially loading for efficiency, then leveraging modern mobile storage, net energy saving, and measurable memory reduction. Uh, so we have this strategic RAM disk approach called EcoVector. Then the selective content reduction, which is the SCR, optimizing the generation, which is we are having a similar computation, then selecting and merging, and then reordering. In the similar computation, the retrieval document is first segmented into smaller sliding windows, typically in individual sentences. Each of these segments then undergo a recalculation of its similarity score against the original user query, and then selecting and merging only those sentences with windows that achieve a higher similarity score are retained. Reordering, now that we have a condensed chunks of text that are re-ranked based on the new granular similar scores. This ensures that most relevant and coherent information is present to the LLM in optimized order, and minimizing the extra data that we are sending. So why this is important? Because it overcomes the limitations of traditional approaches like context loss with native chunking and inefficiency of model based compression. The true MobileRAG advantages are full context retrieval. So we have this MobileRAG initially retrieves document with their full context intact, ensuring high recall and reducing the risk of missing critical information during the initial search phase. Then we have lightweight local refinement instead of heavy model inference. For compression, MobileRAG uses a lightweight vector mathematics for local refinement and content reduction. Then significant input size reduction, as SCR processes effectively reducing the LLM input size by 42 for datasets like Squad, 32 for Trivia QA, all while maintaining zero accuracy loss. Empirical results, speed and memory efficiency. Rigorous benchmarking has on Samsung S24 was shown here. So it was 1.72x faster than the traditional way, and 10.7% reduction in memory, which is pretty good. Validation of RAM disk strategy, even the reduction inclusion of disk IO. The strategic reduction of the search space through the small cluster graph makes EcoVector faster than the brute force search approach. Then these are the results and parallel power efficiency. We have retrieval power saved for 61%, total pipeline save was around 42%, 40.2%. The core reason, small inputs and faster generation was the main goal, and these are the results that were achieved after this when this method was used. So yeah, that's about it. uh, Thank you so much. Bye.